All right, in 4.3, to start with, we're going to factor some quadratic expressions. So let's just start with that. To understand how to do that, let's go back to something like this. In the last section, this was stated as rewrite this in standard form, which meant multiply these together. This is where we would used to, maybe in Algebra 1, say FOIL. I remember to FOIL these. But since we're going to be doing more complicated, not in this section, but or in this chapter, but future chapters, we're going to be doing more complicated multiplication problems. We're going to forget about FOIL. No more FOIL. Just the beautiful distributive law. So that came down to distribute everything in here to everything in here. So we're going to start with x. We'll start from left to right. We'll start at x. We'll distribute x to everything in here. So distribute x to x. That's the first thing we see. That's x squared. Distribute the x to the next thing. That'd be a negative 2. So that's a negative 2x. And we could keep going, only there's nothing to keep going with. There's nothing left in this parentheses. That was the last thing. So now we'll move on from x to 3. We multiply 3 times x. That's 3x. Multiply 3 times negative 2. That's negative 6. We will put together like terms. Negative 2x plus 3x. That's a positive x. And minus 6. Okay. Let's do that again. Let's just grab another example. X plus 5 times x plus 3. All right, so distributive law says distribute the x to the x, that's x squared. Distribute the x then to the 3, that's 3x. If we could keep going, we would, but we can't. We just have two things to distribute to, so we'll move on from the x to the 5. 5x. 5 times 3 is 15. X squared, we're going to put together these two x terms. That's going to be 8x plus 15. Okay, let's do one more. Do a red here. X minus 3 times x minus 1. So we'll distribute this x to this x. That's x squared. This x to this negative 1, that's negative x. And we're done with the x. It's done all it can do. It's distributed to everything. So now we move on to negative 3. Get a negative 3x. Negative 3 times negative 1 is positive 3. Put together the like terms. X squared minus 4x plus 3. Okay. So in order to clearly understand factoring, it's very useful to understand that it's just a working backwards of what we've just done. What we just did here was called multiplying. We just multiplied these two binomials. This is a binomial and this is a binomial. We multiplied them together and got what we got. So factoring would be going not from here to there, but from here to there. Okay, so going this direction is called factoring. Taking it from standard form to intercept form, basically, that's factoring. Okay. In order to make that a pretty simple process, let's just notice a couple things. Notice what we wound up with versus what we started with. And if we can notice that connection, we can move from here to there. And that'll be our factoring process. Okay. So let's notice something about each of these and the last number. Just trying to get it's kind of a bright, attention-getting color here. This one's okay. So let's look at the last number in each of these. How did we wind up getting that? What we call the constant, right? There's no variable in that term, just a number. Where did that number come from for each one of these? From the exact same place, right? The only way to get a constant is to multiply two constants together. Well, yes, let's just say that that's true. We get a constant from multiplying two constants together. So here's a constant. There's a constant right there, 3 times negative 2. Just the number times the number, where x was not involved in any way. It was just the number times the number gave us our constant. Right? 5 times 3 gave us our 15. Negative 3 times negative 1 gave us our positive 3. Okay? So as we work from our standard form, like this, to our intercept form, to a form that looks like this, say x plus m times x plus n. Okay. What we're going to be given is something like this. It's in standard form. So we don't know all the steps we may go through to get to here, but we'll have some ax squared plus bx plus c, c being our constant. So let's go back again. Where did this c come from? It came from these two numbers multiplied together. So something that we know is that m times n, whatever they're going to be, that's what we're going to be looking for. They're the mystery numbers here. Those are really the two numbers we want. The only two numbers we really want to find, and we'll be able to write it in factored form. M times n will always give us c. That's what I love about math or anything that you can just say, this has to be the way it has to be. This m times n, it must give you c every time. There's only one constant in this standard form, and it's got to come from m times n. Okay? So that's great. That's one thing that we can find out. And we just know one thing about these two numbers. If we knew one more piece of information about these two numbers, that would put us in a place where we could find them. What else do we notice about these two numbers we're looking for, m and n? Well, we noticed a connection with the constant. Now let's look at a connection with, let's grab gray here. This number right here, this one's a 1. So what about this number? This number, the coefficient of x. Where did that come from? Well, each time you can see we got a negative 3 here, a negative 3x. A negative 1, we get a negative 1x. A positive 5, we get a 5x. Positive 3, we get a 3x. Positive 3 here, we get a positive 3x. Negative 2, we get a negative 2x. Right? That makes sense. If we just look at each one of these, we distributed. At some point, 3 is going to get multiplied by an x. There you go. At some point, negative 2 is going to get multiplied by an x. There you go. There's two x terms with 3 and negative 2 as the coefficients. Then you're going to add them together, and that's where this number comes from. That's where the 1 comes from. That's where the 8 comes from. That's where the negative 4 comes from. So in each of these cases, we know that in the factored form, this number plus this number will be the coefficient of x. 5 plus 3 gave us 8. Negative 3 minus 1 gave us negative 4. 3 minus 2 gave us 1. Any other multiplication of two binomials that we get, the exact same thing's going to happen. Let's throw another one out there. X plus 5 times x minus 2. Let's make sure. Yeah, I don't have that. So we should see that these two multiplied together is going to give us our constant term, and these two added together should give us this coefficient of x. So let's work that out. X times x is x squared. Here we go. Here's our 5 times x. Here's our, let's see, we did that kind of out of order, didn't we? Don't want to confuse you. Okay, so there's our x squared. Then we'll take the x times negative 2. Okay, so there we go. We have negative 2 times x. And now we're done with the x. We'll multiply 5 times x. Look at that. We have this as a coefficient of x as well. And then the 5 times the negative 2, just like we had already said, that gives us our constant. And we put these together, and that gives us how many x's there are. That's 3x. That's our coefficient of x. So these two numbers, the two numbers really that are the most important, if we add them together, m plus n, that should give us this guy here, b. So looking for two numbers, they multiply to make the constant, and they add to make the coefficient of x. All right. That is the most important thing of, well, I don't know about the most important. It's the first thing. And then we'll go into why are we doing this? Why would we even factor this? So what we're going to do in the sample problems is go from this, something that looks like this, to this guy here. Go from this to this, from this to this. And we'll also answer why. Why would we do that? Okay? So I'll see you in the next video. Thanks for watching.